Okay, this is just quick going through the lecture today on acid nomenclature and organic nomenclature for those of you that missed or for those of you that just need extra practice. Okay, so naming acids. Basically what we're looking at here is we're going to have acids that are bound to nonmetals and acids that are having to do with the polyatomic ion. So let's first talk about nonmetals. So those are the binary acids, and the formula we're going to use is we're going to have the name of our nonmetal. We're going to drop the ending and add an ic. And then after that, we're going to put a hydro in front. For example, if we are looking at chlorine, we're going to drop this ending, add a hydro in front. So to say, it would be hydrochloric acid. And that's just talking about an element or a nonmetal. When we get into talking about the polyatomic ions, we're talking about the carbonate, bicarbonate, sulfate, sulfite, all of those. And depending on the name is what we're going to change the ending to. So if our polyatomic ion ends in 8, we're changing that ending to an ic. So, and there's also no hydro. So for example, if we had sulfate, it would be sulfuric acid. And then if it ends in an ite, we're changing that to an us. So if we have sulfuric acid for sulfate, for sulfite we have sulfurous acid. Alright, so let's just go through a couple examples because I know we went through most of these in class, but let's start again. So the first step is we have to recognize, are we dealing with a polyatomic ion or just an element. So we already did that one, so let's look at this one. So we have hydrogen and sulfur. Sulfur is not a polyatomic ion, so we know that we have to put hydro in front. And then we have sulfur. We're going to drop, this one's a little weird. We should be dropping the ending, but this actual ending is sulfuric. Oh, sulfuric acid. I know it still looks like sulfur. It still looks like sulfur, but that one's just kind of a weird one where you're not going to drop the full ending. So then we have sulfuric acid. So let's look at this one. So we have nitrate, which is our polyatomic ion. So what we're going to do, so we're ending with 8. So our ending is going to be ic. So we have nitric acid. And this one's a weird one. So we have our polyatomic ion cyanide. But we're going to treat this cyanide like it's a binary acid. So we have hydrocyanic acid. Okay? So let's do some of these on the bottom. Let's do these two. So we have nitrite, which is our polyatomic ion, so we know that it's not going to start with a hydro. So we're doing nitrite, so our ending's going to be us. So we have nitrous acid. And here we have dichromate. And we know it's a polyatomic ion, so we're not going to start with hydro. So we have dichromic acid. I know it's going a little out of order, but let's do this one as well. So we have hydrogen and nitrogen. Nitrogen is not a polyatomic ion, so we know we're going to have to do hydro. And our ending's going to be ic, so we have hydronitric acid. So it is important that we have this hydro because we have a hydro here with nitric, and then we have nitric by itself. And that's a big difference between a nitrogen and a nitrate, so we need to make sure that we remember to put the hydro or to leave the hydro out. Okay, when you're writing formulas for acid, the most important thing is knowing if it starts with hydro, then you're dealing with an element. or a nonmetal. And if it does not start with hydro, then you know you're doing the polyatomic ion. And then when we talk about the hydrogens in front, you're going to have to look at the charges. So, for example, you have, sorry, someone was at the door. Okay. For example, you have chromic acid. Okay, there's no hydro in front of it, so you know that it's going to be a polyatomic ion. So you look, and you find, oh, chromate. Chromate has a -2 charge. So you're going to have to go 1 for 1 with the hydrogens, because remember, hydrogen is a +1 charge, and we want our molecule to be neutral. So since chromic acid, well, since chromate is -2, you're going to have to put 2 hydrogens in front, and then you just finish it off with a polyatomic ion. And then when you get to hydroselenic, you're looking, you're saying, okay, there's a hydro in front, so let's find our element. Well, it's selenium. Now, what charge is selenium? It's 2 minus, so we have 2 and then selenium. Okay, and then we're looking at acetic acid. Well, it doesn't have a hydro in front of it, so we're looking for our polyatomic ion, and we find acetate, and that's a -1 charge. So we know we only need 1 hydrogen in front. So it's going to be hydrogen, and then you're just going to finish it off with your polyatomic ion. And then you have perchlorate. It does not have a hydro in front. So you're looking for your polyatomic ion, and you say, oh, perchlorate, I found it. It's a -1 charge. So you're going to have 1 hydrogen in front. And you're just going to end it off like that. I know there's some extra practice, but we already did some examples, so we're going to move on to organic. Now, with organic, I know this chart looks overwhelming, but there's basically 2 things you have to know. When you're looking at substances, or when you're looking at molecules, excuse me, you have to know the prefix. The prefix is going to tell you the number of carbons, okay? So meth is 1, eth is 2, prop is 3, but is 4, pent is 5, and it keeps going all the way down to oct. And then you're going to find out the functional group. Now, the functional group is going to tell you how many hydrogens there are when we're dealing with alkanes, alkenes, and alkynes. Now, alkanes are all single bonds for these molecules, so they're going to have the most number of hydrogens. Alkenes have a double bond, so they're going to have a little bit less number of hydrogens. Alkynes have a triple bond, so they're going to have even less number of hydrogens. And then the only other functional group we're going to talk about are the alcohols, and that you're just going to add an O for the oxygen, because an alcohol group is an OH, as you see over here. Oh, whoops. Is an OH. So you're going to have an O at the end of your formula. Alright, so I know it's overwhelming, but let's just do some practice problems. Okay, again, so let's talk this through. Pro means 3. So we're going to have 3 carbons, and then ane means all single bonds, so we're going to use that formula to find the number of hydrogens. So we have 3 carbons, and that 3 is going to be the N. So we have 3 times 2 plus 2, 8. And then we have pentane. Pent is 5. Ane means we're going to use 2N plus 2 as our formula. So we have C5, H10. And then we go to butane. But is 4. Ane, 2N plus 2. So we have C4. Oh, I'm sorry. That's why I was like, this is actually 12. Sorry. 2N plus 2, 10 plus 2 is 12, and this one is H10. Sorry. Alright, then we have 2-butene. So what this 2 is telling us is it's telling us which carbon a functional group is happening on. So since we have this ene, we know we're going to have a double bond somewhere. So this 2 is telling us where the double bond is happening. So let's just first find, we know but is 4. Ene means we're going to use 2N as our formula. So we have C4, H8. Now, if I was going to draw this out for you, we'd have 4 carbons. And then we have to look, okay, let's count our carbons. 1, 2, 3, 4. That double bond is going to happen on the second carbon. So then we can just fill in the rest of our hydrogens. Each carbon needs 4 bonds. So these are all hydrogens. And then we can count. 1, 2, 3, 4, 5, 6, 7, 8. So our formula works. We got C4H8. And then butanol. So for butanol, we have to pay attention to 2 things. Well, 3 things. We've got but, which is still 4. And then this is our ane. So we know we're only going to have single bonds. And then our all is telling us that we have an alcohol group. So what we're going to do is we're going to have 4 carbons, and then we know ane, so we're going to use our formula 2n plus 2, so we know that we're going to have 10 hydrogens. And then, because of that functional group, we know we have an oxygen. So let me just draw this for you. So we've got they're all single bonds. One of this is going to have the functional group OH though. So that didn't tell us, it doesn't matter which one. And then we're going to fill the rest in with hydrogens. So let's count the hydrogens. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So even though this hydrogen is not directly bonded to the carbon, because it goes carbon, oxygen, and then the hydrogen's bonded to the oxygen, we still count it in our formula. So that's how we can get the same number of hydrogens and then just put that oxygen on the end. So those are some you can practice. Let me just show you this one with propyne. So we have prop is 3. Ine, the formula we're going to use for that is 2n minus 2. So if we have 3 carbons, we have 6 minus 2, so we've got 4 hydrogens. Oh. Okay, sorry, so there's all your hydrogens. Alright, now we just have to count. So we know we have 8 plus 2 carbons because of the 2 functional groups. So we have 10 carbons. And then we're going to count our hydrogens. And we have 22. Alright, so there's all your organic nomenclature. Just make sure you know the prefixes and how to find how many hydrogens. And if there is an all at the end, that's going to be an alcohol functional group, so you're going to add an O to the end of your